Hi, I'm Goh Zee Xin. I'll do the demonstration for project 1. So the circuit design is same as the given inside the project file. So this one is the VB and this one is the Vin. So we can vary the Vin value from 0.6 to 0.895 and 1.2. So M1 is NMOS, which is L equal to 0.25 μm, Y equal to 2.5 μm. M2 is NMOS, which is L equal to 0.25 μm, W equal to 6 μm. M3 is PMOS, which is L equal to 0.25 μm, W equal to 0.65 μm. So first I will do the simulation for 0.6 and then for the manual hand calculation, I will assume gamma and lambda equal to 0. But at here, I will assume the gamma and lambda equal to the value given inside the appendix. So the model CMOS N and the model CMOS P is used for the SPICE level 1. And .include is used to input the TSMC SCM025 file and TSMC 180 file. And .op is used to find the operating region. So first I will simulate for SPICE level 1. So this one is the operating point for SPICE level 1 and this one is the VL. And then from the SPICE error log, we can get the ID, VGS, and VDS for M1, M2, and M3 and calculate the operating region for M1, M2, and M3. Next, I will proceed to TSMC SCM025. So this one is the operating point for TSMC SCM025. This one is the VL. And then this one is the SPICE error log. And then from here, we can get the ID, VGS, and VDS. And then we can calculate the operating region for M1, M2, and M3. Next, I will proceed to the simulation of TSMC 180. So this one is the operating point for TSMC 180, and this one is the VL. So this one is the SPICE error log, and we can get the ID, VGS, and VDS for M1, M2, and M3, and then calculate the operating region for M1, M2, and M3. Next, I will change my Vin to my second set 0.895 volt. And then first, I will simulate for the SPICE error 1. So this one is my operating point for SPICE level 1, and VL is equal to 1.23. And then this one is the SPICE error log again. I can get the ID, VGS, and VDS here for M1, M2, and M3, and then calculate the operating region for M1, M2, and M3. Then I will simulate for the TSMC SCM025. So this one is the operating point for TSMC SCM025. This one is the VL. So this one is the SPICE error log. I can get the ID, VGS, and VDS here for M1, M2, and M3, and then calculate the operating region for M1, M2, and M3. Lastly, I will do the simulation for TSMC 180. So this one is the operating point for TSMC 180, and this one is the VL. And then this one is the SPICE error log. And then we can get the ID, VGS, and VDS for M1, M2, and M3. And then we can calculate the operating region for M1, M2, and M3. And next, I will proceed to the Vin equal to 1.2 volt. So I will simulate for the SPICE level 1. So this one is the operating region. So this one is the operating point for SPICE level 1, and this one is the VL value. And this one is the SPICE error log. And then we can get the ID, VGS, and VDS from here for M1, M2, and M3, and then calculate the operating region for M1, M2, and M3. Next, I will simulate for the TSMC SCM025. So this one is the operating point for TSMC SCM025, and this one is the VL. And then from the SPICE error log, we can get the ID, VGS, and VDS for M1, M2, and M3, and calculating the operating region for M1, M2, and M3. Lastly, I'll do the simulation for TSMC 180. So this one is the operating point for TSMC 180, and this one is the VL. And then from the SPICE error log, I can get the ID, VGS, and VDS for M1, M2, and M3, and then calculating the operating region for M1, M2, and M3. So that's all for my demonstration for part 1. Next, I will proceed to part 2. So next, I will proceed to the project 2. So this one is the CMOS inverter from project 2. And then from the project 2, I'm using the standard of 0.25 μm CMOS technology. And my NMOS is in velocity saturation and PMOS in pitch of saturation. The NMOS transistor, I'm using 0.375 μm. And my VM, which is the Vin, is I'm using 1.25 volt. And for my hand calculation, I get my line of the PMOS is equal to 1.3 μm. And at here, the V transient is put as the pulse as the simulation to simulate the transient analysis. So at here also same with project 1. In hand calculation, I'm assuming gamma and lambda equal to 0. But at the simulation, I'm assuming the gamma and lambda is equal to the appendix value. So the input is used to input the TSMC SCM025 and TSMC 180 file. And the op is used to calculate the operating region, and .VTC and .DC is used to find the VTC curve and noise margin, and .transient is used to simulate for the transient analysis. So first, I will do for the simulation of spice level 1 and finding the operation median. So this one is the operating point for spice level 1 and this one is going to be out. And this one is the spice error log for spice level 1. So we can find the ID, VGS, and VDS for MOS and PMOS and finding the operating region for MOS and PMOS. Next, I will do the simulation for TSMC SCN05. So this one is the operating point for TSMC SGN025. This one is the V out. And then this one is the spice error log, where the ID and VGS, where I can find ID, VGS, and VDS here for PMOS and MOS, and then find the operating region for M1 and M2. Then I'll do the simulation for TSMC 180. So this one is the operating point for TSMC 180, and this one is the VR. And then this one is the spice error log for TSMC 180, and we can find the ID, VGS, and VDS here. And then we can calculate the operating region for MOS and PMOS. Next, I will proceed to the VTC curve for spice level 1. So this one is the VTC curve for spice level 1. So the VM is almost 1.25 for spice level 1. And then from here, we can also get the VIL and VOH when the slope is equal to -1 at the first slope. And then we can also get the VIH and VOL when slope is equal to -1 at the second slope. So when obtaining the VIL, VIH, VOL, and VOH, we are able to find the noise margin value. Next, I will do the simulation for TSMC SCN025. So this one is the VTC curve for TSMC SCN025. We can see that the curve is slightly different with just now the spice level 1. So at here, we can also get the VM value. So the VM value is almost like 1.22 watt. And from here, we can also get in the VIL and VOH when the first slope is equal to -1. And then we can get the VIH and VOL when the second slope is equal to -1. And then we will proceed to the TSMC 180. So this one is the VTC curve for TSMC 180. We can observe that the VTC curve is also different with the TSMC SCN051 and the spice level 1. So at here, we can see that the VM is almost equal to 1.24 watt. And then from the VTC curve, we can also get the VIL and VOH when the first slope is equal to -1. And then we can also get the VIH and VOL when the second slope is equal to -1. Next, I will proceed to the transient analysis. So this one is the V in and V out for the spice level 1, and the bottom one is the V in and the upper one is the V out. So from here, we can obtain the TPLH from the waveform map. And then we can obtain the TPHL from this waveform. Next, I will do the simulation for TSMC SCN05. So this one is the V in versus V out for the TSMC SCN025. The bottom one is V in and the upper one is V out. So at here, we can obtain the TPLH for TSMC SCN025. And then at here, we can obtain the TPHL for TSMC SCN025. And then lastly, I will do the simulation for TSMC F180. So this one is the V in versus V out graph for TSMC 180. And the bottom one is the V in and the upper one is V out. So from here, we can obtain the TPHL. So from here, we can obtain the TPLH. And then from here, we can obtain the TPHL. So that's all for my demonstration video, and thank you.